You are in a car. There is ocean above your head, millions of tons of it pressing down on a thin shell of concrete. The country you started in is not the country you will come out in. No bridge, no ferry, no border you can see. Just a tube lying on the bottom of the sea, stitching together two nations that spent most of their history not exactly getting along. How do you even build that? And what happens if the water gets in? Because that is the part nobody likes to talk about. A tunnel under open sea is not a tunnel through rock. It is a hollow box, lying in the dark, with the whole weight of the ocean trying to crush it and flood it every single second. One bad seal, one section that drifts a few centimeters out of line, that is all it takes. So let's get into how this actually got built and why it almost did not. Start with the problem. The two countries on either end are split by a stretch of sea that looks harmless on a map. It isn't. The water is deep, the currents are vicious, and the weather can shut the whole crossing down for days. For generations, the only way across was a ferry. Slow, pricey, and at the mercy of every storm that rolled through. A bad winter could cut one nation off from the other for the better part of a week. People had dreamed about a fixed link here for over 100 years. Engineers sketched it, politicians promised it, and every time it died. Partly because the sea was brutal, partly because the two countries did not trust each other enough to dig toward the same hole in the middle of the ocean. There was history there, old grudges, the kind of baggage that makes the idea of spending billions cooperating on a once-in-a-lifetime mega project a very hard sell. Now the obvious question, why not just build a bridge? It's cheaper, it's simpler. We've been throwing bridges over water for thousands of years. Here's why it didn't fly. This stretch of sea is a shipping lane, and you can't drop pillars in the path of giant cargo ships. A bridge tall enough to let those vessels through would have to be monstrous, and the higher you build, the more exposed you are to wind, to storms, to ice grinding the supports in winter. Then there's the distance. Too far for one elegant span. That would mean a string of artificial islands and pylons marching across the seabed, each one a target for the weather. And in some spots there were flight paths overhead a tall structure would mess with. So the bridge was out, which left the hard option, go under. And even then, engineers couldn't agree. 3 competing designs were fighting over how to do it. The method they landed on sounds like science fiction. It's called an immersed tube tunnel. Instead of digging down through the seabed like a mole, you build the tunnel on dry land in giant pieces, and then you sink it. Picture this. In a dry dock onshore, workers pour these colossal concrete sections. Each one's a sealed box, hundreds of feet long, capped off at both ends so it's watertight. We're talking sections that weigh tens of thousands of tons, heavier than thousands of cars, stacked together. Then they flood the dock. And here's the wild part. These massive concrete boxes float. They tow them out to sea like ships. Meanwhile, out on the seabed, another crew has been carving a trench into the bottom of the ocean, a long, precise scar in the seafloor, ready to swallow the tunnel. One by one, those floating sections get positioned right over the trench and lowered slowly, carefully into the dark. Blind. Sinking a building-sized object onto a target you can't see in moving water, lining it up with the section already down there so the two can lock together. And that locking is where the whole thing nearly fell apart. Because when you push 2 of these sections together underwater, you have to seal the gap perfectly. The trick is genuinely clever. A rubber gasket gets squeezed between the 2 ends, then they pump the water out of the little pocket trapped between them. The instant that water is gone, the full pressure of the sea outside slams the 2 sections together with thousands of tons of force, crushing the gasket into a seal tighter than any bolt could ever manage. But that only works if the alignment is right. If a section settles wrong, if the seabed shifts under it, if a joint does not seat, the sea finds the gap. And once water starts forcing its way into a tunnel that is meant to be bone dry, you do not get a slow leak you patch on a Tuesday. You get the ocean trying to claim the whole structure. There were moments in this build where one misaligned section threatened to undo years of work, where divers went down into freezing black water to check seals by hand because a camera could not tell them what they needed to know. That is the moment everything hinged on. And they pulled it off, joint after joint, section after section, marching across the bottom of the sea until the two ends finally met somewhere out in the middle. And think about where the middle actually is. It's the point where two countries touch, two governments, two sets of laws, two currencies, sometimes two languages, meeting at a line painted on the wall of a tunnel buried under the seabed. Who's in charge halfway through? Whose police show up if something happens at the exact center? How does customs work when the border's a stripe on the floor with the ocean overhead? These aren't small questions. Lawyers spent years on them. Two nations that had spent a century side-eyeing each other had to sit down and agree on every inch of a structure they'd literally share down in the dark. And none of this was cheap. The price ran into the billions, the kind of number that makes taxpayers on both sides flinch. And not everyone was thrilled. Critics called it a vanity project, a monument to ego, money that could have fixed a dozen ordinary problems instead. Environmental groups warned about what carving a trench into the seabed does to the life down there. The silt thrown up, the habitats buried, the fishing grounds local families had worked for generations, suddenly torn up by construction barges and a permanent wall through the water. Some of those fishermen felt steamrolled. Their side got a lot quieter coverage than the ribbon cutting did. That's the honest picture. A real engineering marvel and a real cost that landed on real people and a real ecosystem. Both things are true at once. But here's what it changed. A crossing that used to mean hours on a ferry, if the weather even let you sail, now takes minutes. You get in your car, you drive, and you come out the other side in a different country before you've finished your coffee. No waiting for tides, no cancelled sailings. Trade that used to crawl now flows. Trucks that used to rot in port queues just drive straight through. Two economies that were neighbours on a map became neighbours in practice. And that's the bigger thing. Two countries' histories kept at arm's length are now physically, permanently fused together under the sea. You can't unbuild that. They're connected in a way no treaty on paper could ever match, and other nations have noticed. All over the world, governments staring at their own impossible sea crossings are looking at this tunnel and asking the same thing. If they pulled it off there, why not here? That's what gets me about this one. The engineers didn't go over the sea. They didn't go around it. They went straight through the bottom of it and dragged two old rivals along with them. So here is my question for you. Now that you know what is holding that ceiling up, would you actually drive through it, or would you take your chances on the ferry? Let me know down in the comments. And if you want more stories about the most insane things humans have ever built, you know what to do. Subscribe, and I will see you in the next one.